This is a single-phase induction motor. Before we get too crazy about how a motor works, I think we need to go back. Way back. This strapping lad is Michael Faraday, and one of his greatest discoveries in 1831 was electromagnetic induction. Faraday's law states the induced electromotive force in any closed circuit is equal to the negative of a blah 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 blah. Or more simply put, when the magnetic field passing through a conductor changes, a voltage is induced in that conductor. Here's the equation for all you nerds. We'll get into that negative sign later. You guys remember when some people were giving me crap for using E for voltage on all my merch and then some of my calculations? Yeah, the E is for electromotive force, you dorks. Merch link in bio, by the way. Let's see if he's full of crap. I just took a bunch of wire, wrapped it around this pipe. I got alligator clips clipped onto either end, and my meter set up to capture the peak voltage. No tricks or anything like that, and I'm just gonna drop this magnet down the pipe. Let's see what happens.
Damn!
What would happen if we hook this up to the oscilloscope? So here's my coil of wire. I've got my scope probes hooked up to it. Move this out of the way so you can actually see the screen of the scope. And here's the magnet. Same thing. I'm just going to drop it down the pipe. There's no shenanigans or anything like that. It's just a coil of wire and a magnet. Just like the meter showed, we have our peak voltage, 4.80. We also have a negative peak voltage, 4.96. If you look at our wave, it's just like an AC sine wave with a positive peak and a negative peak. As that magnet passes through that coil of wire, it's going to raise the voltage. As it exits, it's going to drop the voltage. Depending on which pole of the magnet's going through that coil of wire determines the direction of the polarity. So that's pretty cool, right? I mean, we proved that if you pass a magnetic field through a conductor, it's going to induce voltage. So I just wrapped a bunch of wire around this PVC pipe, dropped the magnet down, and we did get voltage through this conductor. But what if our conductor is the pipe? If we take this copper pipe and I drop this same magnet down this copper pipe, we know the magnetic field is going to induce voltage in the conductor. But if our pipe is the conductor, what's going to happen? If I drop this same magnet down this copper pipe, it doesn't just drop down through the pipe. So we know we're inducing voltage into this copper pipe because that's our conductor now. But what's causing that magnet to float?
We'll float down here.
A lot more to come. Drop a follow.